Okay, here's a question where we're starting with a triangle. In fact, we're given 3 points that we're going to be working with throughout the question. In part A, we've got to get the coordinates of the midpoint of B and C. This is a recipe from Core 1 Chapter 3, which you can look up in your notes. But if you couldn't do that, don't despair. You don't need to have done that to do part B. There are re-entry points all over the place here. Find the gradient of AB in its simplest form. So there's A, there's B. Once again, I think it's the third method in Chapter 3. Either draw a diagram or do 2 subtractions correctly and calculate the gradient of AB. In its simplest form means you are expected to cancel down the fraction. Hence, that means using what you've just done, get an equation of the line AB. Now for the equation of a straight line, again from Chapter 3 you've got a recipe beginning y minus y1, and the things that you need equals, and the things you need to put into that recipe are a point and a gradient. It's always nice to see those as subheadings in your solution. In this case, the point is easy. You've got 2 to choose from, because it goes through A and through B. And the gradient is a hence question, using something you've already done. So the gradient and the point should be both able to be just written down. Set up your y minus y1 recipe. Do rearrange it into this form. And Q and R have to be integers. That means whole numbers. So multiply up to get rid of any fractions. In 3, we've got to find an equation of another line. So once again, we're going to need a point and a gradient. This time it goes through C, that will help with your point, and it's parallel to AB, so that's where the gradient's coming from. And then in part C, we've got to prove that that the angle ABC is a right angle. Now, from other papers, you may have seen questions where the lines that you set up give you a cunning way to do things like this. But in this particular case, I don't think, by all means do draw the diagram, but I think the easiest approach is to go back to the points A, B and C and think about a direct approach. You can work with distances and use Pythagoras, but it's long. The best way to do it is to work with gradients, and you've already got the gradient of AB. So we know the gradient of AB, so therefore you need to look at the gradient of BC and make a convincing comment about those 2 numbers to show that you're aware of what right angle means in a context of gradients. Chapter 3 will help.